All right, so let's look at one more example, see if we can do everything from scratch. All right, so let's sketch the graph of this function. All right, so the first step that we have to do is to factor the numerator and the denominator. The numerator should be easy for you to factor. The denominator is a little bit trickier, but note that -1 is a root of this polynomial. You can just plug -1 in and you'll see you get 0. So knowing that fact should help you factor the denominator. You can use the remainder theorem or the factor theorem to help yourself out. Okay, so pause the video now. Go ahead and factor the numerator and denominator. Okay, so you factored these, and this is what you should have gotten. Maybe you wrote your factors in a different order. That doesn't matter. Now what we're going to do is we're going to cancel common factors to simplify this. I see that x minus 3 is a common factor, and 3 goes into 6 2 times. So we can write this down as follows. Now, one thing I want to note is that we have canceled factors. This function is defined when x equals 3, whereas this function was not. Notice that x equals 3 made the denominator 0, whereas that is not occurring here. So this equality is only true when x is not equal to 3. Otherwise, this one's defined and this one is not. So we exclude that value. We also note that because the original function was not defined, but this one is, we're going to have a hole in the graph at x equals 3. Now, what other features can we see about the graph? Well, this expression, the simplified expression, is undefined when x is -1 and when x is -2. Those two numbers make the denominator 0. So the function is going to have vertical asymptotes at x equals -1 and x equals -2. One more thing to observe is the horizontal asymptote. The horizontal asymptote we get by looking at only the leading terms of the original polynomial. So I block out all the lower order terms, only look at the terms of the highest degree here, and I simplify this resulting rational function. Notice the x cubes cancel. 3 goes into 6 twice, and I'm left with 2. So I know that y equals 2 is a horizontal asymptote. Okay, so let's put all this together and sketch the graph of our function. We said we had a vertical asymptote at x equals -1 and at x equals -2. So there are my vertical asymptotes. We said we had a horizontal asymptote at y equal 2. So right through here. There's the horizontal asymptote. Now, what does the function do in between? Well, now we're going to have to do a little bit more investigations. So let's go look at the simplified form up here and see what we can deduce. Well, I want to know, is the graph up here or down here when x is greater than 0, say, or to the right of this vertical asymptote, I guess greater than -1. Should I be drawing a curve up here or should I be drawing a curve down here? Well, we can tell by just taking a number for x in this region and plugging it in. So if I take x equals 1, I'm going to plug it into this expression. What do I get? Well, I get 2 times 1 times 4, so that's 8. And in the denominator, I get 2 times 3. That's 6. 8 divided by 6 is 4/3. That's giving me a value a little bit above 1. So I see that we're going through a point over here. Now I know that it has a horizontal asymptote, so it's got to go and get close to this curve. So it'll approach this way. Now be careful because we said that it was undefined when x was 3. So I'm going to put a hole there above 3. Okay? Now it has a vertical asymptote over here. So it's going to come down and approach that vertical asymptote. Now what value is it going to cross on the x-axis? Well, note that when x is 0, the whole expression is equal to 0 because the numerator is 0. So it must go through x equals 0 right there. So it's got to go like this. All right, so I've just graphed part of my function. Now let's see what it does in this region over here between x equals -1 and -2. First of all, what happens when we approach -1 from the left? So imagine a number slightly less than -1, plug it into this function. Well, if we are slightly less than -1, then this is negative, right? This is positive, this is positive, and this is negative. So we have a negative divided by a negative, and so the whole thing is positive. So I know that when we're to the left of -1, we're actually up here. Now what if we're close to but greater than -2? Well, if we're close to but greater than -2, that means that this term is positive, because we're greater than -2. This term is negative. This term is positive. And this term is negative. All right, so the whole resulting expression is positive. So again, as we approach -2 over here, but greater than -2, we're positive. So what must happen is it must stay positive in this region. So it must do something like this. The other alternatives were for it to come down like this or come down like that, but then it would have to become negative. But we observed that when x is in this range, in this interval, that it can only be positive. Now what happens when x is less than -2? Well, if x is less than -2, this term is negative. This term is negative. If it's close to -2, this term's positive, and this term's negative. So we have a negative divided by a positive. The whole thing is negative. So it must be going down like this. Now where does it cross the x-axis? Well, that is the second number that makes this whole expression 0. That's the thing that makes the numerator 0. We found the first one. When x is 0, the numerator is 0. Well, also when x is equal to -3. So -3 is right here. That's where it crosses the x-axis. So I know it has to go something like this. And we know that this is an asymptote, so it must approach that asymptote. So this is a picture of my graph.